Hi, this is Andrea Hendricks, and I want to discuss with you higher degree inequalities. Higher degree inequalities are really just an extension of quadratic inequalities. So everything that we learned about how to solve those we can apply to these types of inequalities. Really the focus of this material for you is going to be to solve one that's already been factored, so you don't really have to do anything to the problem except set those factors equal to 0. So when we solve the inequality using the boundary number method, if you recall that was the method we used to solve quadratic inequalities, the first thing that you do is start by solving the equation. So we would solve x plus 3 times x minus 2 times x minus 4 is equal to 0. Well, it's factored, so we just set those factors equal to 0 and solve. So we get that x is equal to negative 3, x is equal to 2, and x is equal to 4. The next step is we place those on the number line in order from smallest to largest. And then we have to test a point from each of these regions that are formed. Notice since we have 3 solutions, we have 4 regions to test. Everything less than negative 3, between negative 3 and 2, between 2 and 4, and larger than 4. So again, let's reiterate what we're trying to do. We're trying to find the values of x that make this value, this expression, x plus 3 times x minus 2 times x minus 4, less than 0. So what values of x do we plug in and make that inequality true? So we'd have to test from region A something less than negative 3, let's say negative 4. So we're saying it's negative 4 plus 3 times negative 4 minus 2 times negative 4 minus 4 less than 0. So we get a negative 1 times negative 6 times negative 8. I'm not multiplying negative 4 times 4 there. Sorry, that's negative 8. Is that less than 0? Well, negative 1 times negative 6 is 6 times negative 8 is negative 48, which is less than 0, so that is true. So we would shade region A because solutions lie in that region. In region B, we need to plug in something between negative 3 and 2, and you guessed it, my favorite number is 0. So we're asking ourselves, is 0 plus 3 times 0 minus 2 times 0 minus 4, is that less than 0? So that is 3 times negative 2 times negative 4. 3 times negative 2 is negative 6 times negative 4 is positive 24. Is that less than 0? No. In region C, something between 2 and 4 would be 3. Now let me say, if this happened to be 2 and a 3, then I'd have to use like 2.5 or some decimal value between 2 and 3. But since we have an integer between those two, it makes it a little bit nicer to work with. If I plug in 3, I'm saying is 3 plus 3 times 3 minus 2 times 3 minus 4 less than 0. Well, this is 6 times 1 times negative 1, which is negative 6, which is less than 0, so that is true. So regions A and C contain solutions thus far. What about in region D? If I put in 5, is 5 plus 3 times 5 minus 2 times 5 minus 4 less than 0? Well, 5 plus 3 is 8. 5 minus 2 is 3. So 8 times 3 is 24. Times 1 is 24, which is not less than 0. So that one is false. So only regions A and C contain solutions to this inequality. Now, what about the endpoints? Since I'm not allowed to include the solutions, I put parentheses. So my solution to this would be from negative infinity to negative 3, then union 2 to 4. Okay, if I have two pieces shaded, I've got to have two regions for my interval. Now, can I do this an easier way? Yes, you can on the calculator. If on the calculator you input what is opposite from 0, right, so we're going to input the x plus 3 times x minus 2 times x minus 4 in the equation. And if I graph it, remember what the solutions mean, that negative 3, that 2, and 4 are my intercepts. So if I divide up the number line, excuse me, and put the negative 3, 2, and 4, notice what happens. To the left of negative 3, the graph is below the x-axis. Between 3 and 2, it is above. Between 2 and 4, it is below. Well, I should write that below down here. And to the right of 4, it is above. So since I'm trying to find where it's less than 0, that means where it's below the axis. That happens between the numbers that we just found when we plugged in by hand. And we know we can't include the endpoints. You can also look here with testing. Like if we plugged in something to the left of negative 3, like negative 4, we get a negative 48, which is less than 0, so that checks. Between negative 3 and 2, all of those values are greater than 0, so that doesn't satisfy my inequality. Between 2 and 4, which is at the 3, we get a negative 6, which is less than 0. And then to the right of 4, everything else becomes positive. So the calculator can really save you a lot of work, that tedious work. Another example, if I wanted to solve x times x plus 2 times x minus 2 is greater than or equal to 0, I first solve the associated equation by replacing the inequality with an equal sign. And so we get x is equal to 0, x plus 2 is equal to 0, or x minus 2 is equal to 0. So our three boundary numbers are 0, negative 2, and 2. Putting those on the number line in order from smallest to largest, we again get 4 intervals to check. We'd have to plug in something smaller than negative 2, say negative 3. Something between negative 2 and 0, say negative 1. Oops. And something between 0 and 2, let's say 1. And something larger than 2, we would say 3. So we're saying it's negative 3 times negative 3 plus 2 times negative 3 minus 2 greater than or equal to 0. What is that? Negative 3 times negative 1 times negative 5, which that's positive 3 times negative 5 is negative 15, which is not greater than or equal to 0. That's false. If we plug in negative 1, we're saying it's negative 1 times negative 1 plus 2 times negative 1 minus 2 greater than or equal to 0. So we get negative 1 times 1 is negative 1 times the negative 3 is positive 3, which is greater than or equal to 0, so that's true. We plug in positive 1, we would have 1 times 3 times negative 1. But if we multiply those three numbers together, we get negative 3, which is not greater than or equal to 0, so that is false. If we plug in 3, so we'd have 3 times 3 plus 2 times 3 minus 2. Is that greater than or equal to 0? Well, this is 3 times 5 is 15, times 1 is still 15, so that is greater than or equal to 0. So the intervals that contain solutions were region B and region D. Now what happens on my endpoints? Since I'm allowed to equal 0, I can include those endpoints. So my interval is from negative 2 to 0. union 2 to infinity. So remember what this is saying. All the values of x between these numbers satisfy this inequality. That is, they make it true. Now, to solve that one on the calculator, remember our problem was x times x plus 2 times x greater than 0. So we plug in this expression in y1. So that's really referring to y. So we're trying to find what values of x make that y positive or 0. We confirm our intercepts for -2, 0, and 2. And so we know left of -2, the graph is below the x-axis. Between -2 and 0, the graph is above. Between 0 and 2, the graph is below. To the right of 2, the graph is above. Well, we want it to be greater than or equal to 0, so that means where it is above the x-axis or on the x-axis, and that means we can include the endpoints to get our region. And then also the table confirms those values that we plugged in. If we did -3, we got something that wasn't greater than or equal to 0. If we plug in -1, we get something that is greater than 0. If we plugged in something between 0 and 2, we get something that's not greater than or equal to 0. And if we plugged in something larger than 2, we got something that was greater than or equal to 0. So really, once you solve the equation by hand, you can let the calculator assist you with the other testing part. Okay, so call me if you have any questions or email me. Thank you.
Facebook.